questions. All right, here we go. We are on quiz 11 for Unit 6, and we're going to go through and do the work, and we'll see what questions we have, and hopefully this is able to answer some as much. We'll go over whatever we need to in class this week, so make sure you check this out. All right, so, and I believe this is a calculator active quiz. And of course, I didn't check that, but let me, hopefully this is not doing this one, but yes, calculator active. All right. So the velocity of a particle, v of t, is given by the function v of t equals t squared cosine t plus 2. If the position of the particle at t equals 2 is 10, what is the position when t equals 5? Awesome. So real quick, they're giving me velocity, and they're asking us about position function. So I got to go to the integral of velocity. I don't need that. Sorry, I want to use this pen, but I don't know if it's going to let me. All right, v of t dt, and I know this is equal to the position function. So I just got to pay attention to that a little bit. Now, they said at time equals 2, they gave me the value, and they're trying to find time equals 5. So that's where I get these two. Okay, and now I know I'm evaluating from 2 to 5. Okay, so this is the key part here. So, and I'm going to do this part on the left on the calculator. I'm going to get that. I'm going to get most of this answer on here. So now this is equal to the position at 5 minus the position at 2. And I don't know what the position at 5 is, but I was told the position at 2 was 10. So really, whatever I get for an answer here, I'm going to just add 10 to it. Okay, so position 5 equals 10, and then whatever I get for this. And I'm going to do that on the calculator right now. So this is the beauty of having the calculator, is we can just type this in. Now let's hope the calculator works here. T squared cosine t plus 2. All right, calculus, see what you got here. All right, it's a good sign. So t squared, again, we don't do t here, we do x. So there's x squared, and then it was the cosine of x plus 2. I'm in, not 22. That would have messed up my stuff here. How do I delete that? Delete. Okay, so I want to go to, that's my v of t. Let me just peek at it to make sure. Cosine of t plus 2. Okay, good. So, yep, I got t squared cosine t plus 2. Why is it saying 22 still? All right, no, it's not. Okay, x plus 2. Okay, so now I'm going to go to my home screen, and I'm going to use my calculator to solve this. So I'm going to hit the math button. I'm going to hit choice 9, and we are going to go from 2 to 5, I think we said, and I'll have to look in a second to make sure that's true. And it's only in y1, so vars, y vars, function y1, and I'm taking the integral. The variable of integration is x. Okay, even though it's t on my problem, we always use x. So, and I just want to confirm that I'm going from 2 to 5, 2 to 5. All right, good. I don't want to mess that up. Get this answer, and I said we're going to add 10 to that for my answer. So there's 36.7777, and number 7 I have is E. Let me just make sure. That's quiz. Am I doing the test right here? Oh, I just did number 7. Sorry. All right, so we're starting at the end. I'll go back and do number 1. Sorry, I just took one of the harder problems and did that one. So this is quiz 11. I was wondering why it didn't say no calculator. So this problem ends up being E. All right, good. Let's come back to the beginning. All right, graphing calculator permitted. I was wondering why I didn't see that. And I was thinking I was doing part 2 of the test. All right, let's jump into number 1. So with our graphing calculator, we have these values 0, 0.5, 1, 1.5, and 2. A table of values of a continuous function is shown above. If 4 equal subdivisions of the interval 0 to 2 are used, what is the trapezoidal approximation of the integral from 0 to 2 fx dx? Okay, first of all, they tell us how many equal subdivisions, and so 0 to 2. So it's really, I'm doing 0 to 0.5. There's my second one. There's my third one. There's my fourth one. Okay. All right. So I need to go through, and because they're all by 0.5, I'm going to use my the shortcut. I'm going to say, hey, it's 1/2. The height is always 0.5. And now we're going to do what we know, that the sum of the bases, the first base is only used once. The second base is used twice. Really, every other base except the last one's going to be used twice. 5 times 2 plus 8 times 2 plus 13. And that's only used once. So when I add these up, hey, this is 6, this is 10, this is 16, 3 and 13, 16, 32, 42, 48. And we should have 1/2 and 1/2 is 1/4, and 1/4 of 48 is 12. Okay? And that ends up being our answer. Now, if you did it the long way, you would have done, hey, 1/2 and then 3 plus 3, but then you would have done 1/2. And again, all these are, remember, area of a trapezoid is 1/2 sum of the bases times the height. Okay? And now we would have done each one separately, which is fine. Either way. Okay? Sorry about doing number 7 first. All right, let's jump over to number 2. Pictured to the right is the graph of the derivative, and they label it, which is good, of a function. What is the value from 0 to 4 of fx dx? So even though we have the calculator, what we're trying to find out, the integral is the area between the curve and the x-axis. So I'm going from 0 to 4. So from 0 to 2 is this triangle. That's a positive value. And then from 2 to 4 is below the x-axis. This is a negative value between the curve and the x-axis. So let's go through and find these areas. So this is a triangle, 1/2 base times height. 1/2, the base is 2 and the height is 4. And now let's do the area. Now, either way, whether you just do negative because it's below the x-axis, you know it's going to be negative. And again, the integral of any function, and this is the function of the derivative, is the area between the curve and the x-axis. So because they gave us this, I'm just finding the area. So I'm looking at 1/4 of a circle, pi r squared, and the radius here is 2. Now, a lot of times we could put in -2 there, either way, but 2 squared. 2 squared is 4, 1/4 of that's just pi. And here's 8, and 1/2 of that's 4. And number 2 should be E, and it is. Okay? So again, the concept that the integral of anything is the area between the curve and the x-axis. All right, now for this one, I'm going to need the calculator. So average value of a function. So let's just go through and just talk about, in general, average value of a function is always written as 1 over b minus a. Okay, so we're going from 0 to 2, so we're going to take 1/2 of whatever we get for a number. So I just want to be able to do this on a calculator, and what it's going to look like, 1 over 2 minus 0, the integral from 0 to 2 of x squared. And again, we have access to a calculator, so we don't have to do this yet. In Unit 7, we might have a problem like this that's not a graphing calculator, and we'd have to be able to figure this out. dx, okay? So that's what I'm going to type in, and that's obviously 1 over 2. So let's go to our calculator here, and let me see if I can set this up first so I can see both. All right, so on my calculator, I have y equals, I'll leave this here. So I like to put it into the graphing part. Oop, I meant to shut off that. I no longer want to graph that. I don't want that to be the active one. But I like to just have it there in case I need to graph. And so this is x squared times the cube root. So, and I just want to show you the button on the calculator here. I have to do, so I can't just do the square root. I think I have to go in the math. Wait, was this a square root? I might be messing this up. No, it is the square root. If I ever had to do the cube root, I go into math, there's the cube root. If I had to do the 4th root or 5th root, that's right here. You just put the number first, then you put x. Or I think you hit that, and it would allow you to put in the number. So it's the square root, which I can just do second square root of x cubed. I have too many x's. Delete that. So x cubed, and then make sure we get out of that, and plus 1. Okay, so I'm still under the radical. Perfect. So I just did all this. Now I want to go and do the math that I said I was going to use my calculator to do. So 2 things I could do. I could multiply by the half up front, or I could do it at the end. I usually do it at the end, but that's okay. So now I'm going to do the integral, choice 9, from 0 to 2 of this x squared. And I could have, if I knew I didn't have to graph it later on, which sometimes it's hard because we're not sure on a multiple choice problem. Multiple choice, if you know you don't have to graph, you can just do the answer. So I could type that x squared times the square root of x cubed plus 1 right here. Free response questions, you're almost always going to have to graph it at some point. So it's good to have that. So I'm going to do vars, y vars. Now remember, it's function, but it's y2. You just got to pay attention where you put it. And then we're going to do this with respect to x. And this should spit out my final answer. 2.8888. And let's make sure that's in there. All right, so 2.8888 is going to be, so if I look here, let's go back and check the math. I think it's the 26 over 9. 26 divided by 9. That's my answer, okay? And that's A. All right, so they give it to us as a fraction. Where's my red? So we just said the answer is A, okay? Not B. Sorry about that. All right, but an average value, okay? That's the 1 over B minus A. That's from day 54 homework, or day 54 notes and homework. Okay, let's go on to number 4. Okay, if the integral from A to B of fx is A plus 2b, now let's do this. All right, so I got to use my properties of integrals. So this right here is the integral of a sum. I can break it up to the sum of 2 integrals. So fx dx plus the integral of just 5. So this right here I know is A plus 2b. Perfect. Well, now this is going to be 5x, and we're going to evaluate it from A to B. Use my fundamental theorem of calculus. So let's come down here. So we just get A plus 2b. Now I'm going to evaluate at the upper limit, 5b, and then I'm going to subtract, evaluating from the lower limit. And I keep pushing that button, sorry. That's just 5b minus 5a. Let's try writing that again. Without pushing the button, 5b minus 5a. And 2b plus 5b is 7b. A minus 5b is minus 4a. And looks like choice C. Let me just check the answer. Yes. So that's it. Again, even though we can have access to the calculator, and I could have, oh no, I can't because it's got B's and A's in there. So we still have to do it by hand. All right, number 5. Picture to the right, and the guys at home, just make sure you're hollering out questions as they come up. All right, don't, if you see something that you're not sure of, just ask. Picture to the right is the graph of the derivative of the function g prime of x. They do not have it labeled. I always want you to label it. You start doing the problem, especially if there's part 1, part 2, and then you forget what the graph is. Okay, so they tell us g of 0 equals -3, and what is the value of g of -4? So whenever they're giving us something as the derivative and they want us to find the original function, we're going to deal with the integral. So we're looking at, hey, the integral, and I'm going to go from -4 to 0. Why? Because they give us x is 0, and they want us to find when x equals -4. So the integral of the derivative, using the fundamental theorem of calculus, is g of 0 minus g of -4. Okay? So this right here, this part's going to be the area under the curve, which I can figure out, right? From -4 to 0. All this right here, and I'll come back and do that. And g of 0, they gave us. Hey, they said that was -3. And this is what I'm ultimately trying to find, minus g of -4. Okay, so now what I have to do, the calculus, is the area under the curve. Well, if you look here, I have a 1 by 1 triangle under the x-axis. I have a 1 by 1 triangle above the x-axis. They cancel out. I have this rectangle that's 2 by 1 above the x-axis. So it's 2 times 1, that's 2. 2 go up 1. And then I have a quarter circle plus 1/4 pi r squared. And it looks like my radius is 2. So again, that's 4 pi, and a quarter of that's just pi. So this is 2 plus pi equals -3 minus g of -4. So I got to pay attention to signs here. Add 3 to both sides. So I'm going to get 5 plus pi equals the opposite of g minus -4. And this negative sign, when I divide both sides, so I just added 3 to get that 5. When I divide both sides by a negative, this is going to give me b, okay, because both those are going to be negative. Again, they're trying to trick you here. So it's very important that I understand that it was subtracting g of -4, okay? So when I divide both sides by negative here, I have to divide both sides, or multiply, same thing. And then that negative is going to distribute through to each term, and we'll get a negative, okay? All right, hopefully we're good with 5. All right, let's take a look at number 6. A spherical tank contains 81.637 gallons at time equals 0. So that's our initial amount. That's going to be important. For the next 6 minutes, water flows out. Ooh, so we're taking it out. That's going to be what we subtract from it. At a rate of 9 sine square root of t plus 1 gallons per minute. They don't call it f of x, g of x, h of x. That's fine. But flowing out, so we know it's going lower. How many gallons of water are in the tank at the end of 6 minutes? So the integral from 0 to 6 of the rate of water flowing out, I'm just putting in words right now, flowing out, equals total amount of water in gallons that left. So if you can understand this, you are okay. Again, remember, the integral of a rate is going to be the total amount of change that left the tank. Okay, so now all I have to do, and again, this is a calculator problem, the integral from 0 to 6 of 9 sine square root of t plus 1. And I'm going to get that total amount of water that went through. And then I'm going to do the 81.637 minus this total amount that left. Okay, so that's going to be the key. So let's get our calculator out. It's kind of nice with our calculator working. I'm just going to do it right on the home screen. So math, choice 9. We said for 6 minutes, 0 to 6. I can't remember what the function is. 9 sine. And I'm going to do the square root of, even though it's t plus 1, we use x plus 1. Where are we here? Where's my x? X plus 1, and I just want to double check that I'm, see? Double hitting buttons here. X plus 1. Let me make sure it's plus 1 and not minus 1. X plus 1. Perfect. And it's within dx. Now, this is not my final answer. So let's get this answer. Enter. And remember, I started with, and let me write the full number down. And look, 45.031, that is a choice. They are trying to trick you. So you got to read the question. So it's 81.637. And here's a little thing we can do so we don't have to remember things. 81.637 minus, and then when I hit second answer, which is above this negative sign, it'll take your last answer so you don't have to retype it in. Perfect. So now 36.605, and that is choice A. And that is the correct answer. Okay, so that answer button is always really good. Now, let's say I messed up and I did x plus 1. No, let's say I messed up and it was supposed to be 7 sine instead of 9 sine. I can hit second entry. It brings up the last thing I typed in, hit second entry again. I think it'll go through the last 10 things. And now I can come in and edit this to whatever I want to, whether I want to do sine or 7. Maybe instead of sine, it was cosine. Or maybe I had to do the same function again from 0 to 12. So that just allows you to edit it without typing the whole thing over again. Obviously, time is precious. And that was second entry, which is above the enter button. Okay. All right. I did number 7. Let's look at what we did. So they gave us the velocity. So I took the integral of velocity, which I used the calculator to get that answer. And then used the fundamental theorem of calculus because I want to find the position at time 5. So the integral of velocity is equal to the position function from 2 to 5. So fundamental theorem of calculus says p of 5 minus p of 2 equals the integral of velocity over that interval. We used the calculator, got an answer, added 10, and then we were able to find out what position it was at time equals 5. Okay, perfect. All right, let's look at the free response here. So what do we got here? Particle is moving along. Let me move this. I don't know if that shows up on your screen. A particle is moving along the x-axis such that the velocity v of t measured in feet per second at any given time is graphed at the right. And they were nice, and they labeled it. Use the graph to answer the following questions. What is the value of v prime of v? And explain using correct units what this value represents. Oh, that's the derivative. That's the rate of change of velocity. So at 5, where are we here? So, wait, such as velocity at any given time. That is the rate of change. And what do we got here? 2, 4. Oh, this is 5. I thought this was 5 right here. So this is the value 5 right there. And it's on this segment. So it is the derivative, which is, again, the rate of change. So I just find the slope of this. So let's look what I do here. I'm at 3, and I go down 3 over 1, down 3 over 1. So v prime of 5 is, again, 1, 2, 3, 4. That was 5 right there. is equal to -3, because that is the derivative, that's the slope of the tangent line, which just happens to be the slope of the segment right here. And that is in feet per second squared, because velocity is feet per second. And what does that mean? It represents the acceleration at time equals 5. That's all we have to put. Okay, and that's 2 points. 1 point for the answer. I think you lose a point if you don't have the unit, and then 1 point for what it represents. All right, I think we have to come back to this picture on the next one. So on what time interval, if any, is it moving to the right, and justify your answer? Well, hey, I know it's moving to the right whenever velocity is positive. So it's positive here, here, and here. So from 0 to 5, and then again from here and here. So from 7 to 9. So we know it's moving right on 2 different intervals. 0 to 5, not including the 0 and 5. And 7 to 9. Okay, and how do I know that? Moving right when the velocity is positive. V of t is greater than 0. Perfect. Okay, what is the value of the integral of v of t dt from 0 to 9? And explain the meaning of this value. So remember what the integral stands for. It's the area under the curve when it is that. So we're looking for, and this is a calculator, but they don't give us a function. So I'm actually going to do, I need to find all this area and all this area. Okay, and remember, integral of a rate is the amount of change, total amount of change. Okay, and I can't forget this. This area right here is going to be negative, obviously. Okay, so this is the integral of velocity, and that equals the total change of the position function from 0 to 9. So that's what we're looking at. We're trying to find the net distance, and I shouldn't say the total distance because the total amount of change, but it's in this case it's going to be the net distance. So where I started from, where I ended. Okay, because we're doing the both the positive values and the negative values. I think part D asks about the total change. Okay, so that's gonna, and I should just leave that as I've been saying total amount of change. It's just the amount of change. Okay, and we'll get to the total change in a little bit. All right, so let's come back here. All right, let's first see if I can cancel anything out. I believe this will cancel out with half of this one, because that's 3 and 3, and then the other half of this will cancel out with that. So for my thing right here, this is from 4 to 1. So that is a 3 by 3, that's 9. And this is a 1 by 1, so that's a half. Oh, no, sorry, that's 1 by 3. So it's 3 halves. All right, that goes a height of 3. And this is 1 by 3, so that's 3. So should it be 13 and a half, I hope? Yeah, so from integral from 0 to 9, dt dt equals 13.5. And what was the amount of change? It was the distance in feet. Okay, and that represents the net distance. And now when I come back here on D, when they have this, now I want the total amount of change. And so what that does is the absolute value tells us that the negative part down here is now going to be included. And let me do this in blue. So this was 3 halves. This was 9. This ends up being 1 by 3, and half of that is 3 halves. This is 2 by 3, which is 6, and half of that's 3. This right here was 3 halves. And then in the red there at the end was 3. So it now, instead of these canceling out, we add all those back in. So 9, 12, 15, 18, 19 and a half. So our total distance is 19 and a half. Okay? So that's our total distance. Because the net distance, where we start, where we end up, and this is the total distance traveled even when we went to the left. Total distance traveled from 0 to 9 seconds. Okay. All right. So that's everything for quiz 11. Let me pause this.